today we're going to learn the laws of logs. We have the logarithm of a product, the logarithm of a quotient, x divided by y, and the logarithm of a power, x, some argument to a power here. And we want to kind of think about it a little bit in terms of what we did with our exponents. Remember, when we had exponents, when you multiplied two numbers with the same base, you could add the exponents. So if I'm multiplying my arguments, I actually can add two logs. When I divided with my exponents, right, I subtracted my exponents. And when I had a power raised to a power, I multiplied it. So you can kind of see the connection between our exponents and our logs. But that's not good enough. Let's go through and prove that these are true. We're going to start off with the idea of just letting log base a of x equals some variable. Let's call it m. And log verse base a of y is equals to n. So basically, we've just called this m and this n. Okay? And we want to mess with it. So first of all, we're going to start with these two ideas. And we are going to say, well, if I know I have it in logarithmic form, I can then change it to exponential form by looping it, right? The base of my log to the m equals x. The base of my log becomes the base of my exponent to the n equals y. And now if I look at taking x times y, I can multiply those together. And so then this becomes log base a, and instead of writing x, I write a to the m. And instead of writing y, I write a to the n. And now because we have the idea that I have the same base, and I am multiplying, so I'm looking just at the exponentials, so a to the m times a to the n. I have the same base. I'm not paying any attention to this log base a, but I know that the rule said if you multiply, you add your exponents. All right, and then a log property we learned yesterday was, or maybe not yesterday, but a while back, we have log base a of a to anything always equals the anything. So therefore, this equals m plus n, and we let m equal log base a of x, and we let n equal log base a of y. And so we have shown that log base a of xy is the same thing as log base a of x plus log base a of y. Okay, the proof for division is very similar. If you think you want to try it, go ahead and pause and start the same process I just did. All right, so again, you see that we have division here. So we're just going to start off by calling this m and this n just like we did last time. Turn it exponential, so a to the m equals x, a to the n equals y. And now when I do division, instead of writing x and y, I'm going to write a to the m divided by a to the n. I'm going to use my exponent rules that we learned. If I'm dividing with the same base, that means I just go ahead and subtract my exponents. And then again, from our property we learned a while ago, log base a of a to the n is just going to be n. So we know that's just going to be equal to m minus n. And we called m log base a of x. And we called n log base a of y. And so we have proved that log base a of x over y is the same thing as taking the difference of the logs. All right, one more property to prove. Start out with the same idea. We're just going to let log base a of x equal m. Okay, so I'm just going to write that as m. And I need to then prove that I can go ahead and take this power and just put it right in front. I've got to prove that, so I don't want to put that arrow there, but that's what I'm trying to prove. Okay, so first thing I did was then, this one's a little different than the previous ones. I'm going to raise both powers, so I'm going to turn it exponential first. So a to the m equals x, just like we did on the other ones. But what's different is I'm going to take both powers, both sides, and raise them to the b. If I do it to one side, I can do it to the other. My exponents rules say if I have a power raised to a power, I just go ahead and multiply that. Okay, so I just now what I'm going to do is turn it back into logarithmic. Okay, so now convert back to logarithmic form. Okay, which means this becomes the base of my logarithm. All right, the answer becomes the argument, and the m plus n becomes the equals. Okay, so I becomes the answer here. So when I write this, I write log base a of my argument x to the b equals m times b. Okay, again, you might want to just check it. I always have a little bit harder time going from exponential to logarithmic, but if I just throw that visual in there for you, a to the m times b equals x to the b. That turns it right back in there, so I can see that I did convert it to logarithmic correctly. And now you can see that this is the left or the right hand side, right? This is exactly the same as this, and we have m times b, but we called, and I'm just going to write that b times m because multiplication is commutative, we called m log base a of x. So I have now shown that log base a of x to the b equals this b times log base a of x. All right, now that we have those proved, let's use them. All right, so let's simplify these by using our law of logs rules, and then we can evaluate them later. But right now we're just going to start with simplifying. So have the idea that you see subtraction. So that means you go ahead and just take your log base 2 of 96 over 3, and 96 divided by 3 is 32. So we have simplified this to log base 2 of 32. Now, there is a very common mistake people generally make when they're doing this. This is not log base 2 of 96 divided by log base 2 of 3. So you're not writing this. I'm going to put it up here, and then I'm going to erase it right away. There's a very big difference between taking two logs and dividing versus taking the arguments and having it be division. You do not write log base 2 of 96 divided by log base 2 of 3. Okay, so try to stay away from that common mistake. Now we could evaluate that if we want, because if that equals x, turn it exponential, 2 to the x equals 32, and we ask ourselves what power of 2 gives us 32? And our answer is 5. All right, here we can do the same thing here. I get to move that 2 up. So I can write as log base 4 of 8 squared, not times 2, 8 squared, which is the same thing as log base 4 of 64. Again, if we wanted to evaluate, we could loop it. But let's just work with the properties for now. And last one, you see plus, that means you are going to multiply your arguments. So you're looking at log base 4 of 8 times 2, which is equal to log base 4 of 16. If I wanted to evaluate, loop it, 4 to the x equals 16. This answer is just 2. Just direction said just simplify, but if we want to evaluate, we can go one step further. All right, same sort of question here. We want to just use, you see the plus sign, so you should think multiplication. So log base 6 of 36. All right, same thing here. Got another extra step. We have a plus and a minus, so that means let's read it like we would a book. We're going to multiply here first, so that's going to be log base 7 of 8 times 5 minus log base 7 of 2, and then because you see the minus, so we have log base 7 of 40 minus log base 7 of 2. Minus means divide, so then we would go ahead and do 40 divided by 2, and our answer is just log base 7 of 20. So the missing value they want here is 20. Now you can do this all in one step. I just wanted to pull it apart so you could see what I was doing. So if I do 8 times 5 divided by 2 right away, all right. So if I just see, oh, I can just go ahead and multiply those together, divide by the 2, you're still going to end up with the 20. I just wanted to take it step by step so you could see what I was doing. All right, same thing here. Again, if you've got this, practice and then restart it and make sure you got the right answer. So this is just going to be log base 2, 7 divided by 3 times 5. And so 7 divided by 3 times 5 is just going to be log base 2 of 35 thirds, which doesn't happen to be a nice number, so my answer is just 35 thirds. Okay, try another one. The power rule tells me I'm going to do that. And you need to do that exponents before multiplication, just like you kind of learned PEMDAS, right? We need to make sure we do exponents before multiplication. So then I have log base 5 of 16 plus log base 5 of 3. And because of the plus sign, we know that means multiply 16 and 3 together, and that ends up with 48. So we have log base 5 of 48. So we're just practicing using these laws so we can evaluate things later. Give you one more here. Stop, pause, see if you get the right answer. All right, hopefully you got log base 8 of 25 halves. If not, look back at my notes and make sure you see how it's done. Again, you have to do your exponents first. Okay, so now we're going to get into solving some equations. Okay, we're still going to use our properties. So if you see minus, that tells you, oh, that means I need to divide my arguments. Okay, again, you don't have 2 logs, you just have this 1 log out here. Now you don't see a base, but because there is no number here, we know automatically that it's a 10. And if I need to solve for x, I've now got to turn it exponential. So I loop it, and I do 10 squared equals this whole argument. All right, 10 squared we know is 100. And now I got to start solving for x. This one's a little bit harder to solve for x, but we got to get rid of the fraction. So you can either cross multiply, put that over 1, and then just say, okay, I've got x plus 1 times 1 equals 100 times x minus 1. If I just cross multiply. And so I have 100x minus 100 on this side equals x plus 1 on this side. And so then we just combine our x's. So I have 99x, add the 100, equals 101. And now divide, and we have x equals 101 divided by 99. Okay, let's do another one. This one's similar, different base. Okay, and we got a plus sign. So plus means we're going to have to go ahead and multiply our arguments together. Okay, if we multiply, make sure we are FOILing. So I'm going to just do x squared plus x minus 1 equals 0. Combine my like terms. And now we're at this point where we have to turn it exponential. So that's kind of your key to solve these, to solve logs. Always turn it exponential. Okay? Not always, but a lot of times. And you'll find out when we solve exponentials, you're going to turn it to logs. So they're inverses, they work well with each other. So I need to see, okay, no base here, but I know since it's ln, my base is e, and then I just loop it. E to the 0 equals x squared minus 1. And I know e to the 0 is 1. And then I go ahead and add 1 to both sides, and I get 2 equals x squared. And I go ahead and take the square root. Remember that when we take the square root, we always have to do plus or minus. But we have to be careful because then we go talk about our domain of our log graph. And we know that our domain our argument always has to be positive, right? Okay, so if that's the case, will both the square root of 2 and negative square root of 2 work? And you can see if I put negative square root of 2 minus 1 in here, that gives me a negative number, right? And you can't have ln of a negative number, and so therefore the negative does not work, and we are left with just the square root of 2. All right, let's try another one. If you've got this idea, go ahead and pause the video and see that you can do it on your own. All right, multiplication means I'm going to, or addition means I'm going to multiply. Make sure you FOIL. So I have x squared minus x minus 3x plus 3 equals 3. Combine my like terms. And then turn it exponential. So if I turn it exponential, I have 2 to the 3 equals x squared minus 4x plus 3. Arguments all one thing. 2 cubed is 8. And now we got to solve this. All right, and hopefully we're thinking, okay, how are we going to solve this? And we see this little guy here, which tells me this is a quadratic. So I know that when I'm solving quadratics, I've got a couple ideas. I can factor, or I can use a quadratic formula, but I know I have to have it equal to 0 on this side. All right, and then some of you may be factoring, some of you may be doing quadratic formula. It's completely up to you. Just make sure you can do it without a calculator. All right, so I need two numbers that multiply together to give me 5. Well, there's only two of them, 1 and 5, and they have to be -4, so the 5 has to be negative. The 1 has to be positive. Last thing we do is we set each one of these equal to 0. Some of you may remember that benchmark that we all had to pass in order to proceed with the factoring. And so then we subtract 1. One answer is x equals -1. Well, we don't know for sure. I'm going to leave it as x equals -1 and x equals +5. We go back and check. If I put -1 in here, -1 minus 1 is -2. And so this guy does not work. All right. But if 5 minus 3 is good, 5 minus 1 is good. All right, so 5 works, -1 does not work. Please be careful to think it's not just because it's a negative number here. It means it's a negative argument here. Okay, so you have to check the argument, not your answer. All right, I'd like you to try this one on your own. All right, walk you back through the process. You multiply. All right, let's walk you through the process. You see the minus sign, should be division. You know your base is e, so you turn it exponential. Please remember, anything to the 0 is always 1. Now I'm going to cross multiply here. And so I have x plus 1 equals 3x minus 1, and then I add the 1, subtract the x, and I get 2 equals 2x. And so divide by 2, and I get x equals 1. Got to check to make sure that works. So if I put 3 times 1, yep, that'll work. 1 plus 1, that'll work. Our answer's good. Just better to get in the habit of checking to make sure your answers always give you good values in the domain. All right, last one here. Go ahead, give it a shot. Check your answer when you're done. All right, not gonna lie to you, this one's just ugly. So hopefully your first thing you did, because this is where a lot of people make mistakes, do the exponents first. Remember, exponents come first. So hopefully we didn't divide first. We put the 2 up, and so we have log base 10 of 2x plus 1 equals log of x minus 1 quantity squared equals 1. Then we turn it using our property because it's minus. We divide our arguments. And then we turn it exponential. So I have 10 to the first equals that whole argument there. Then I cross multiply. Then I FOIL x minus 1. Make sure you FOIL. You cannot distribute powers, right? We know that a plus b quantity squared is not a squared plus b squared. It's major, right? Then we distribute the 10 through. And put everything on one side. And now we have a quadratic, which actually cannot easily be factored. So we go back to this quadratic formula. Some of you might be seeing Pop Goes the Weasel or other fun quadratic songs. Check out YouTube if you haven't seen any, because they're pretty funny, some of them. Of course, I am a math nerd, so I enjoy them. All right, then we acknowledge that our A is our first term, B is our second term, making sure to grab the negative, and C. And so when I plug it in here, I have negative 22 plus or minus. Parentheses are key. Do not forget your parentheses around b squared. Okay, because you got to make sure you square the negative. Now, some people just don't even put the negative in there because they know when you square a negative, it becomes positive. So either way you're doing that, I don't care. Just make sure this parentheses are here so that becomes a positive value once you square it. Minus 4ac all over 2a. And then my two answers, when I plug them into my calculator, were 1.65 and 0.543. All right, if you can do that one, you're doing well. All right, and that is it. And tomorrow we will work some more in class. Have a great night.